have a new project. This is our new project. This is called Overcharge Protection for the battery. Lead acid battery. It can be used for lead acid battery. Just like this one, lead acid battery. So if this is overcharge protection circuit, let us test the circuit. We're using the adjustable workbench power supply for the testing. So we're going to vary the voltage, the input voltage of the circuit. Well, because we are just like simulating a battery, as if we are going to charge a battery. So here in our circuit at 0 volts, now this is a simulation as if we have a charger connected to the circuit. So it seems we have a charger connected to the circuit. It is just like a charger, or simulating a charger, or doing the same as the charger. What if we have a supply of at 3 volts? We now have the power LED color blue, and then we also have, that is the lowbat indicator color LED red LED. So you can see here blue LED for the power, red LED, it means that our battery is lowbat. So as the voltage is increasing, let us increase that to, now we are approaching 7 volts. Still increasing as if you are charging the circuit. 10 volts, 12 volts. So at 12 volts, we still increasing the voltage. Okay, at 14 volts. Now we have this green LED that turns on. It means that our battery is fully charged. So full charge. So at 14 volts, as if this is our charger, simulating the charger, or doing the same thing as the charger to the circuit, at 14 volts, this is full charge for the lead acid battery, and we have this 12.8 battery voltage. This LED display is connected to the output of the battery, or I mean to the battery. So it means the battery is now full charge at 12.7 or 8, and our supply is 14 volts. That is the charger. And how about the moment that the battery is we're using the battery? So it means we're simulating again. What if the battery is now depleting? So you can see there's no output. It means it is lowbat. And also we have this red LED that turns on. It means that the battery is low battery. At 10.98 cutoff, that is the auto cutoff, that is the cutoff voltage for the battery. In order that the battery not to discharge too much, so we have this cutoff voltage of 10 or 11. So again, if we're going to charge it again. So we have again this voltage, 12.4 volts. Actually, in the actual charging of the battery, it is 14.4 volts charging voltage of the battery. And the nominal voltage of the battery is 12.4. After charging, it will become 12.4 for the battery. What if we're going to transfer the voltmeter at the input? It means we're having almost the same charging voltage. If this LED display is connected to the charger or the input voltage. But if this is connected to the output or to the voltage of the battery, we're now having this 12.5 volts compared to the 13.63 voltage of the charger. So this is also, in short, this is acting as a charger. And then the power blue LED is the power LED. And we can adjust the cutoff of the, in order to protect the circuit over we can adjust the cutoff voltage using this potentiometer. As you can see here, if I'm going to turn it, for example, going to turn it, we can now adjusting the cutoff. So you will see now the cutoff is 12.9 volts to the battery, and when you use the charger of 14.05. So the potentiometer can adjust the cutoff voltage for the overcharging. So if you just want a less charging, for example, less cutoff, we can set that to, for example, 10. So that is 10 or 9.23. So we can set the overcharging voltage value using this potentiometer. If we're going again to adjust, so you can now adjust the overcharging. 13.2 now is the overcharging voltage to the battery. Before it's 12, now it's 13, and the charger is 14. Current is 0.052 ampere, 0.728 watts. We now come to the overcharge protection schematic diagram of our battery. We are using a transistor 547 BC, which is an NPN type transistor with relay, and also with relay, using relay. Okay, this is the relay. In our circuit, we have this power LED. So, power LED blue, color blue. The red LED is the low bat indicator. Power indicator, blue LED. Red LED is the low bat. And then green LED, full charge. Full charge. Green. Low bat, red. So when we have the red LED is on, it means it is low bat. If we have the green LED, it is full charge. And if you have blue LED, it means we have the power. So that is the color of our LEDs indicator. So in the initial state of the circuit, we have this, what's this? Supposedly, this is a charger. Of course, we need the charger to charge the battery. So, here is the charger. This one is the battery. We're going to charge the battery from here to here. Okay. During the initial state of the circuit, it is charging. What is the voltage, charging voltage? In standard charger, we are using 14.4 volts for lead acid battery. So we are dealing with lead acid battery. It is 14.4 volts and usually 5 ampere. That is the standard commercial current and charging current, charging voltage. So, 14.4 volts. It is not 12 volts. 14.4 volts. We're going to charge this battery. And we need this whole circuit as a protection for overcharging. Why is it that we need a overcharge protection circuit? In order not to damage the battery. And overcharging the battery will damage the battery. Okay? During the charging process, when we connect the charger to the protection circuit and to the battery, so if this is the charger, and then connected is the protection circuit and then the battery. So we have this block diagram: charger, protection circuit, battery. So during the charging, this blue LED. So we have this blue LED that turns on. And then it passes through the overcharge protection circuit. The current flows into here. That's why we have this power LED. It's using 6.8 kilo ohms resistor to the blue LED in order not to damage this LED. Power indicator, it turns on, and then current flows here. Where now is the current flows? Is it going to flow here or here? Current flows where? Here. Because we are charging to the COM3. Okay? COM3, or the, if this is the relay, we have 3 pins here and then 2 pins COM3 is located at the center, COM. This is coil 1, coil 2, there is a coil here, and then normally closed somewhere here, normally closed, normally open. So we have 5 pins for this relay. It is connected to the center or to the pin 3 COM. And since this COM is normally connected to pin number 5, which is normally closed switch, it is now connected to this LED, 380 ohms red LED. It turns on this LED, and with this fast switching diode or current steering diode to the battery, so it is charging. It is charging. Why is it charging? Because if this is charger, it is a supply, and then battery is also a supply. Since this charger is has a more potential, remember, more potential energy will cause to charge this battery. This is low potential because it is low watt, so it will continue to charge through this line. It turns on the red LED, it means it's charging, and then passing through this current steering diode. Now, green LED is off. Why? Because there is no circuit, there is no current that flows into the green LED. Remember that this is a contact point. It is movable. This contact point. And then this green LED is off. It means there is no current that flows here because it is connected to the normally open or pin number 4. Pin number 4 pin of the relay. So now our circuit is this LED red is on because we are charging due to the potential difference between the two supply. We have the battery and then we have the charger. Now, the current will not flow here, and also here will not flow here because it is charging. Okay, so since there's no current that flows into the transistor, there is no way that this green LED will turn on. Now, what if the battery now is full charge? What happened to the circuit? It will, the current, if this battery is, for example, has a, we set the battery overcharge protection to 12.5 volts. If this is the overcharge protection voltage value, if this is full charge, the tendency now of the circuit of the current is to flow into this branch, and it will not flow this because the potential difference between the charger and the battery is zero. 14.4 volts here and also 12.5 or 14.4 volts here. Zero. There's no current now here into this junction. So potential, it will make this LED to turn off and this green LED to turn on. Why is it that this green LED now turns on if this is a full charge? You see, when the current flows here, it flows into the two resistor that serve as a voltage divider, biasing to the transistor. So to turn on this transistor, we have these two resistors, one fixed resistor 4.7K and the 50K resistor, which is a B10, a B50K potentiometer, adjustable resistor or potentiometer connected to the base of the transistor. We need a voltage between base to emitter to switch on this transistor which is almost 0.7 volts. The value is 0.7 volts. So to turn on this transistor, we need to turn on, to switch on. We can just adjust the base, which is the wiper of this potentiometer. If this is the potentiometer, that is the knob, then we have the pin 1, 2, 3. 1, 2, 3. 2 is the wiper. 3 is ground. So this is the potentiometer, and then 1 is connected to the 4.7K and to the 12 volts, via 12 volts. So it depends on the adjustment of this potentiometer that will turn on this transistor. So we need to adjust that, and that costs to set this overcharge protection voltage value, which is 12.5 volts. Depends on the adjustment of potentiometer. If we adjusted this and has a voltage of 0.7 volts, it will turn on this transistor. If we switch on this base to emitter, the current now flows into the relay coil, and then to the collector, to emitter, and then with these two diode. What's the use of this diode? To prevent thermal runaway or to overheat the transistor. We need at least a diode here, a diode drop, or a resistor, so that the transistor will not overheat. Thermal runaway. Current flows here into the coil, inducing the coil, inducing a voltage, create a voltage, and will now, just like an electromagnet or a magnet, because we are passing the current here, it will now becomes a magnet, just like a magnet, causing the contact to attack, or to moving the contact into pin number 3 to 4, because it now becomes a magnet of the coil, causing the contact to move from 3 to 4, just like the wiper. It moves here to the left, causing the contact to move to 4 to 3. And because of that, transistor turns on. Current now flows into the COM, and then to the 3-4, since the contact is now here, and then turning this LED on green. So that's why it's full charge, and that's why it means it is full charge, and our transistor switch on. And what's the use of this diode, clamping diode or freewheeling diode? The use of this diode is because of during the switching or the contact point moving, or the clicking of the contact point, it will cause this, if the contact point moves to its original position, or when the battery is low bat, it will move again to its original position, and then when charging, it moves again, on off, on off, on off, on off, for this green LED. If this is on, this is off. If this is off, this is on. The tendency is to create a voltage spike because of the switching of this contact point. It creates a voltage spike that producing a high voltage spike or back EMF. Just like there is since this is a coil, it restores energy, cause the current to flow into the circuit after the contact moves to its original position. So it will create a current that oscillates here. Without this diode, it will damage the whole circuit. So we need this diode to protect the circuit. So this is for protection, so that the current will flow caused by the back EMF, or a voltage created by the coil due to the coil, induce voltage with the coil until it the current now will flow again until it is losing its energy. All the current will now flow here because of this diode 1N4007. And again, when this is a low bat, it will turn off again because the contact will now move again to the normally closed terminal. And this LED now, red again, will turn on because the battery now is losing its charge. So it is charging again. And then full charge, turn on this protection circuit when this is full charge, green. So in short, if we have red LED that turns on, it means it is low bat. Green, it means it is charging. So it is due to the on and off of this contact and the switching on and off this transistor that will make the current to charge due to the contact point and to the switching of this overprotection circuit, the on and off of the LED. So when we don't have a charger, here we have this protection circuit, it means we have this red LED. This one is blue, and then if this is charging, low bat, red LED, green LED, full charge. If we don't have the charger, without the charger, this battery will not supply a voltage to the red LED because of this diode. So this diode acts as to isolate the battery from the LED red. So when we connect the charger, it will turn on this red LED. It means it is charging again, the battery also. And then if it is full charge, depends on the adjustment of the potentiometer, it will switching this resistor relay here, turning on now this green LED, red LED turns off. So green LED charging, red LED low bat. Okay, and we connected we are connecting the LED display into the output of the battery. So we need it so that we know the current status of the voltage of the battery by connecting this LED display. So we're going to connect that here. So if the cutoff usually is around 10.7 volts, and then for the low bat, it's 10.7 usually standard, and for the full charge FC it is around 12.5 volts. That is standard. Low bat or the cutoff, in order not to over discharge the battery, it is 10.7 volts. For the full charge is 12.5 volts. It means it is fully charged. 12.5 volts. The battery is full charge. Let us now try the over-voltage protection. We now so it we could not see 10.6 low bat for the voltage battery, and then around 12 volts, 12.5, 12.4, 12.4 cut off. It means it is fully charged. Two point 12 volts. $10.7 low bat, and then 12.4 cut off. That is the battery voltage, as you can see in the LED display, 12.4. So the cutoff voltage is 12.4. That is the overcharging voltage.